Hi. So today I'm going to talk about why has the world of finance has become very quantitative, right? It is not a new thing actually. Finance has been very quantitative for a very long time, right? I think for many decades now. In other industry, the data and mathematical models are being used more recently, whereas in the field of finance, mathematical models have been in use for many decades actually. In fact, it all started in 60s 70s and gained momentum in 80s. And I think in the last 20 years things have skyrocketed. Post financial crisis, things have increased quite dramatically, the use of mathematical models. So why is that the case, right? Why finance is such an exception, right? Why has finance become so quantitative in the last 4 or 5 decades, and will that stop? Will that change over time, right? So I'm going to talk about that in this video. Okay. So the field of finance actually draws inspiration from physical science, particularly physics. You know, the success of physics in using mathematical models to understand behavior of particles, real world particles, electron, protons, quarks, these very tiny particles that you cannot even see, to be able to mathematically model their behavior and able to calculate something to a with great precision is a huge success in the field of physics, especially theoretical physics. Not just the tiny particle, but also the black holes and so on. Or planetary objects that you cannot go and check yourself, but you still do the calculations here sitting on Earth, hand calculation or using computers. So that's a huge success in the field of physics, and people thought, okay, that can be replicated in the field of finance, right? So there are a lot of wonderful blogs actually written about the use of physics in finance, by someone called Emmanuel Dauman. He was a physicist. He worked in Bell Lab and other places before he worked with Goldman Sachs as a quant. So you can check his website. Actually, is it has a lot of amazing blogs about use of science or use of mathematical models in the field of finance. And he's perhaps one of the most cited quant, who has made a switch from pure scientific research to the world of finance, right? And it's not new, right? It all started way back, actually. I think even more than 100 years. One of the French mathematician Louis Bachelor actually he wrote his thesis was PhD thesis was about predicting asset financial instruments prices using mathematical models, using probability models. And that didn't quite go well actually, you know because those days, yeah, it was a bit of a taboo to talk about money in university, and a lot of the professors in mathematics department in some reputed university in France did not like it. So it was quite discouraged. But that really, was then taken up by some of the economists in the US, and they started using that in their own work. Later on, practitioners from finance and insurance started using it, and ever since, it's been in use, and the use of mathematics in finance and insurance has been increasing over time. So it's not new. It's been for a very long time, and it has been a great success actually. There is perhaps not as no other non-scientific field uses mathematics as much as finance, right? All other fields that use a lot of mathematics, physics or engineering or computer science, all that is scientific, right? You cannot find a non-scientific field that uses so much of mathematics, and that's finance, right? And among the the business areas, right, in the industry, the world of financial service and banking uses mathematics or mathematical modeling way more than any other industry, right? Some might argue, okay, well, the new age tech companies are also using a lot of mathematics and mathematical modeling. That's true, but not for every single thing. But in banking and finance, probably for everything, for trading, for lending, for both of these activities, there is use of models for everything. Every single decision you take in a bank and financial service company, that has to will be validated with some sort of data and models output. Otherwise, it is never going to be trusted. Nobody can just take a decision on the money. So money is quite a big thing actually in the economy, and therefore it has to be tested with not just some gut feeling, but also with the data and mathematical models, right? So the various reasons as to why this has happened, right? First is about decision making is practically impossible nowadays without using data and models, right? It's not just true in the field of finance, but also in other places. But in the field of finance, the stakes are very high, right? Something goes wrong, then it is not just going to impact the banks or the financial service company, it's going to impact all sectors in the economy, right? So banking is perhaps the most important sector in the whole economy. And when that gets impacted, all the other sectors will also get impacted. It has happened in the past also. You see, a lot of the crisis, economic crisis that has happened in the past, a lot of them were related to some issues in the financial service industry, right? In the last 2 decades, the biggest was in 2008 finance crisis, or the banking crisis, right? That was related to the world of banking. So the stakes are very high, right? You cannot trust just one person, two-person, or a committee to take a decision. Rather, it has to be based on some theoretical models. And let me also tell you that it's a combination of both. It's not always just the models taking decision on behalf of people. It's a combination of both, right? Both in investment and trading, but also in lending as well. People forget about lending part. Lending is perhaps the biggest business for most banks, and that really affects the entire economy. Trading is a relatively smaller part of the business for most banks, except maybe some US banks who are heavily into trading, but trading is a much smaller part of the business for many big banks. And also for the general economy, what matters really more is the debt part, right? That how easily companies and individuals can get a loan from the bank, and that decision is not necessarily very easy to take just by some loan officer assessing your applications. That's impossible nowadays, especially with the scale at which banks are operating in the different in they're operating in different countries, all kinds of customers. It's impossible to just have a rule book to use in assessing the credit quality. It has to be done through models, and models therefore are so very important. And by the way, these are not necessarily just internal models. Sometimes banks or financial service companies, they buy models from external agencies, particularly the ratings for S&P and Moody's. Those are outputs from different models, credit models, and these are also very much in use, right? And the second reason is why, because it's been decades, these things have been in use, and there is a huge amount of success. The banks, or the smaller banks that did not use models, you don't see them anymore, right? In 60s, 70s, there were some banks who were reluctant to use computers or models and technology, and they are not existing anymore. Most of the big banks you see nowadays are highly quantitative. JP Morgan, Goldman Sachs, Morgan Stanley, Citi, HSBC, Deutsche Bank, right? You name it. All of them are highly quantitative. That means every single thing they do, right? Whether it is about you know on the credit side, but also on the trading side, investment side, merger acquisition, all kinds of advisory. For every single thing they use models, right? Without mathematical models, it's impossible for them to take important decisions. right? The other reasons, one of them is being to have competitive advantage over your peers, right? Um, and that used to be the case actually in 70s, 80s, when a lot of the banks started using models just to get competitive advantage over their peers were not using models, right? Um, for a variety of reasons, right? You can better assess credit worthiness of customers, especially retail customers, using models, and easy to build good models for retail customers. Similarly, assessing your portfolio, monitoring your portfolio, right? That's very important, and that can be easily done using models, right? No single individual can assess a portfolio of thousands or 100,000 customers. That's practically impossible. You really need to then assess it at a group level, and for that you need to have some mathematical equation, right? Otherwise it's very difficult to do that, right? And the same story is in the investment side also, right? You may not realize that if you're managing your own portfolio, maybe not a lot of money, but if you're using other people's money, which is what banks or hedge funds, mutual funds, they do, you really need to track your performance very, 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 very keenly, right? You need to have early warning indicators, just in case you see some stocks in your portfolios are not doing well or not going to do well in the near future. You need to take proactive steps to avoid such a situation, such a scenario where you will make a lot of losses. So for that, models are being used, right? Right. Okay, and it's also about feeling of missing out, right? So quantitative modeling has become so popular that even the mutual funds, the value-based mutual funds, people that look at the financial ratios and invest in different stocks, and even they are also using some sort of analytics, not just looking at the p value or the book value, but also looking at the sentiment, overall sentiment, understanding, forecasting macroeconomic scenario in the future. All that is even looked at by these people who otherwise wouldn't see about the quantitative aspects of decision making. But things have changed because they don't miss out on. So that's the feeling of missing out, that others are using, why not me? So to have that sort of competitive advantage, they're also using that. um, Also, one other thing which is cannot be discounted is the influence of academic world, right? The world of academia is very, very strange. The people in academia, they don't work in industry. A lot of them, especially outside of US. In US, some academic people in academia, they do have some experience. Outside of US, you will barely find people who actually work in academia, who work in industry, and those who are in university. So they have all the flexibility because they don't manage money, they don't take risk. So writing a paper is not a big deal, right? You take some data, you do something about it. So they have this flexibility of doing anything and everything they want to do and publish it, right? And economists, especially financial economists, people working in business schools and all that, they love getting a bit of an attention. So they try all kinds of things. They use neuroscience and how is it used in, how it can be used in finance. Nowadays there is a lot of buzz around how AI can be used in the field of finance, and there are a lot of papers being published. Initial days, some how like some physics concepts, um, like Brownian motion, for example, and simulation techniques for mathematics can be used. Monte Carlo simulation techniques can be used in the field of finance. How econometrics and statistics can be used. So that gained a lot of popularity a couple of decades back. Now machine learning AI is getting a lot of popularity in the field of finance. All that is being heavily used in the field of academia, and professors are writing papers about it, and they also teach a lot of things to their students, and these students go on to work in the industry. Many of them go on to become CEOs of big banks, and therefore they start making they start hiring more and more quants, and make the bank more quantitative in so to say. um, every bank nowadays have a chief risk officer. There was not the case, by the way, a couple of decades back. And it's a more of a control. That means most of the time the chief risk officer has a quantitative background. he must have worked as a quant at some point of his career or her career. So that has also worked, that has also influenced the industry to be more quantitative, because any finance paper, academic finance paper you read nowadays, it's impossible not to find some, mathematical calculations. Some econometrics could be very simple, like linear regression or doing some hypothesis testing, or could be more sophisticated mathematical, like stochastic calculus. Or it could be even more sophisticated, like use of some deep learning model, reinforcement learning models in the field of finance. So all that has come from actually from the field of academia, where it's easy to use anything and everything you want to use, but to implement that in the industry is quite a, tough thing. But because of the influence of academia, things have also changed in the industry to a lesser extent, but it has changed nevertheless, and it is changing at a rate, at a good rate. Yeah, and the final point I want to touch is the amount of data that is available, right? So banks have been collecting customers' data, I don't know for how long, right? For centuries, I would say. Ever since they were there, they have been collecting data. Obviously, these data points were not in the computers or servers. They were in some pen and in some paper, right? In other industry, people don't collect data about the customers. Retail industry, other industry, not long ago, I mean, nowadays they do have some data, but 20 years back, was Walmart or Tesco, were they collecting data about the customers? No, none of them were. So data about customer is available only in the industry like finance and insurance. In other industry, there was none of that, right? That is also helping the bank and financial industry to be more quantitative, because you have huge amount of historical data. Now, to what extent that is useful is questionable, actually. I don't think the consumer behavior back in 1980 is exactly same as now. So what's the point in using that data? But you could still derive some insight out of it. So all that has also played some role in making the world of banking and finance more quantitative. Right. And other thing is about access to alternate data. That's with all industry, but certainly in the field of finance. More recently, we're talking about how climate changes will affect lending and trading in the future, about green financing, about having a ESG score next to your credit score. All that will play a big role. And in order to model for that, it's the most financial organizations now are exploring alternate data that they have not been collecting over the years, but they want to use third party, and for instance, climate data from third party, satellite data from yeah, some private companies, in order to build models to to you know capitalize on the opportunities that the climate risk changes um, is offering, both for profit purpose, to to increase your business, but also for risk management purpose. So where you could face issues in the future if you don't do well. So all that is also playing some. So these are some of the things why quantitative um, banks have become more quantitative in a lot of ways, and it is only going to stay, uh, because the use of computer and computation will stay, right? Will stay with us, right? There is no way it will go away. We will never come back to pen and paper calculation to the at the scale, right? When you are dealing with millions of customers, it's impossible to do anything manually, right? And no human being can do the computation manually. No, not even Einstein, not even the most intelligent man on the planet can do even 1/100th of the or 1 millionth of the computational power that a simple computer has, right? So that is practically impossible. So computation, very important in the field of finance, whether it's assessing risk, whether it is forecasting return, whether it is balancing portfolio, whether it's taking decision on whether to give money to the customer or not, to the to the loan to customer or not, whether to assess credit quality of a SME customer, whether to to um, engage with the relationship with the client for collections purpose. All that is impossible to do manually. You need mathematical models. And what I expect in the future to happen is that these mathematical models will perhaps be a bit more automated, in the sense that a lot of that will be done, be implemented and readjusted automatically. And what the quants will do is basically monitor these models more often. So monitoring of these models and assessing the risk around the model, which is known as model risk management, will be more important rather than building models. Cleaning data and monitoring models will be more important. Building models will perhaps, especially in the lending side, will be less yeah, less of a big deal. I think in the in the trading side or investment side, it will always be. You can never outsource that. You can never buy ratings. You can never, well, you can, but you really need your proprietary algorithm for that, but probably less for lending on the lending side. Okay, so these are some of the things I wanted to share with you. Any questions, as always, let me know in the comment section. So thanks for watching, and see you in another video.